Greetings, and welcome to a story shrouded in intrigue and technological marvels. Today, we delve into the remarkable journey of a single American fighter, a battered P-51 Mustang, shot down over France on D-Day, which would soon become a tool of espionage, experimentation, and revelation for the German Luftwaffe. But how did a crashed enemy aircraft turn into a symbol of American engineering dominance? Could an aircraft recovered from the battlefield expose the true extent of Allied superiority? And what did it reveal about Germany's declining technological edge? Imagine a fighter, torn from the skies, painstakingly repaired using salvaged parts, then transformed into a showcase of enemy ingenuity. How did German engineers, with limited resources and mounting shortages, manage to restore such a sophisticated aircraft, down to the high-performance Merlin engine, the aerodynamically refined wings, and the advanced systems, while their own designs lagged behind? And what did German pilots, flying these captured aircraft in mock dogfights and demonstrations, learn firsthand about the American engineering philosophy? Speed, range, high-altitude endurance, that was rapidly changing the course of the air war? Is it possible that these captured planes, once mere trophies, became the most powerful tools to understand and ultimately confront the enemy's technological advantage? Could the meticulous testing of a downed Mustang reveal weaknesses and strengths that shaped German tactics, and perhaps hasten their strategic decline? And as the Allies' industrial might produced thousands of these fighters, how did the Germans' efforts to analyze and copy these aircraft fall short in the face of overwhelming production, resource shortages, and the relentless march of Allied air power? Today, we will trace the extraordinary story of how one wrecked fighter, through systematic evaluation and daring experimentation, exposed the stark realities of the German war effort, highlighting their technical vulnerabilities and the profound superiority of American engineering. From crash site to testing ground, from propaganda to battlefield reality, this is the astonishing saga of a single aircraft that challenged perceptions, revealed uncomfortable truths, and symbolized the shifting tides of aerial dominance. The most gripping part? The story is only just beginning. June the 6th, in the year 1944, marked a pivotal moment in the tumultuous history of World War II. Somewhere near the small village of Rouen in France, a P-51 Mustang fighter aircraft, battered and damaged, made a desperate descent through a canopy of broken clouds. Its sleek, metallic frame caught the sunlight intermittently as it spiraled downward, leaving behind a faint trail of smoke wafting from its Merlin engine, now trailing a thin ribbon of vapor through the air. The pilot, Lieutenant Thomas Fraser, of the 334th Fighter Squadron within the esteemed 4th Fighter Group, had become disoriented amidst the chaos that raged above the brutal Normandy beaches. His aircraft, adorned with the squadron code QPG and affectionately nicknamed Jerry by its crew, struck the French countryside with a thunderous impact. Despite the crash, Fraser survived, albeit to spend the remaining years of the war as a prisoner of war, enduring captivity far from the skies he so loved. But the aircraft itself, bearing the serial number 43248-25, a P-51B15NA model, was about to embark on a remarkable journey, one that would challenge the perceptions and assumptions held by some of the most seasoned test pilots of the German Luftwaffe. The Mustang rested relatively intact in a quiet French field, a silent testament to the ferocity of aerial combat. Soon, it would be discovered and recovered by German salvage teams, experts who had honed a systematic approach to retrieving captured and wrecked Allied aircraft. Scattered across occupied Europe, within a matter of weeks, this particular fighter would be transported to Arlon, the Luftwaffe's primary testing and evaluation facility. Located approximately 100 kilometers northwest of Berlin in Mecklenburg, Arlen had become a hub of innovation where captured enemy aircraft would undergo detailed inspections, repairs, and modifications. At Arlen, the aircraft would be repaired using components salvaged from other less salvageable wrecks strewn across German-controlled territories. Once restored, it would emerge bearing unmistakable German markings. The fuselage painted with the Luftwaffe code T9+HK, and the tail's underside painted in bright RLM-04 yellow to aid in identification by German pilots during hurried operations in the chaos of aerial combat. The nose of the aircraft received a yellow propeller spinner, and a red band was carefully painted around the nose of the engine cowling. Standard markings intended to prevent friendly fire accidents and facilitate quick visual recognition. Following the established procedures for captured enemy aircraft, this Mustang was destined for service within one of the Luftwaffe's most unusual and specialized units, the Wonder Zirkus Rosarius. This unique unit was tasked with evaluating and demonstrating the capabilities of captured Allied aircraft, transforming them into tools of intelligence and psychological warfare. The presence of a captured American fighter in their fleet was bound to force German fighter pilots to confront an unsettling reality: that American engineering ingenuity, industrial strength, and technological advancement were formidable and perhaps even superior in certain aspects. This, in turn, highlighted the increasingly precarious tactical situation faced by the Germans in the deteriorating air war over Europe. The story of how these captured aircraft became vital instruments of revelation for the Luftwaffe did not begin on the day Fraser's Mustang crash-landed in France. Instead, it was rooted in the escalating aerial conflict across Europe and the urgent need for accurate, systematic intelligence about the true capabilities of Allied aircraft. By mid-1943, the strategic picture had grown increasingly dire for Germany. Despite the remarkable skill and courage of individual Luftwaffe pilots and the continuous development of increasingly advanced aircraft designs, the German air defenses faced growing challenges. American bomber formations, massive, well-coordinated, and increasingly precise, were penetrating deeper into German territory month after month. These formations were protected by fighter escorts whose true capabilities remained shrouded in mystery to their German counterparts. German commanders, tasked with making critical tactical and strategic decisions, often had to rely on incomplete or fragmentary intelligence reports from combat pilots who had limited visibility into the full extent of Allied aircraft performance and tactics. These reports, while valuable, often left many questions unanswered about the aircraft's true strength, speed, maneuverability, and armament. It was against this backdrop of uncertainty and mounting pressure that the Germans saw the potential in systematically examining captured enemy aircraft. By studying these machines firsthand, they hoped to gain crucial insights into Allied technology, tactics, and strategic advantages, knowledge that could influence the development of their own aircraft and combat strategies. The process of capturing, repairing, and studying these planes gradually became a vital component of the Luftwaffe's efforts to understand and counter the growing Allied threat, ultimately revealing unsettling truths about the technological gap between the Axis and the Allies. During the course of the war, countless reports emerged detailing the performance and capabilities of enemy aircraft, but these accounts often conflicted with each other. Reflecting the chaos and unpredictability inherent in aerial combat rather than providing precise, controlled analyses. Such reports, while valuable, were fragmented and lacked the systematic rigor necessary for significant tactical advancements. Hetman Theodor Rosarius, a seasoned and highly experienced officer within the Luftwaffe, recognized early on that fighting an effective aerial campaign against the Allies required more than just piecemeal combat reports and second-hand observations. He understood that to truly understand and counter enemy aircraft, the Germans needed direct, empirical data obtained through meticulous testing and evaluation of captured enemy machines. This process involved not only inspecting enemy aircraft after their crash but also gaining hands-on experience by flying these aircraft under controlled conditions, systematically analyzing their strengths and weaknesses through direct observation and rigorous testing. While the practice of examining captured aircraft was not novel, both the Allies and Germans had engaged in similar efforts throughout the war. Rosarius sought to elevate and organize this approach into a more structured, strategic program that maximized its tactical effectiveness. His vision was to transform these isolated efforts into a comprehensive method of intelligence gathering and technological advantage. In the year of 1943, under direct orders from General Adolf Galland, a leading figure in the Luftwaffe, Rosarius established what would come to be known as the Wonder Zirkus Rosarius. This unit was officially designated as the second staff of the Vakquande Oberkommando der Luftwaffe, the dedicated trials and research unit responsible for testing and evaluating captured enemy aircraft. The formation of this specialized team marked a significant shift toward systematic exploitation of enemy technology. The unit received all repairable Allied aircraft recovered by German salvage crews from crash sites scattered across occupied Europe, from France to Italy and the Eastern Front. These aircraft were not merely examined in static testing setups behind the safety of secure facilities. Instead, Rosarius organized a series of mobile demonstrations and testing flights. This innovative approach brought captured planes directly to operational Luftwaffe fighter bases across Germany and occupied territories, allowing frontline pilots to see and examine enemy aircraft firsthand. These demonstrations enabled pilots to observe enemy machines in action, perform aerial maneuvers, and even participate in mock combat scenarios against them, under carefully controlled conditions. This tactical approach provided invaluable insights into enemy aircraft, revealing their true performance capabilities and limitations in realistic scenarios, which static testing alone could not offer. The program also aimed to address a fundamental weakness in German pilot training that had become increasingly perilous as the war endured and pilot losses mounted. Historically, German fighter pilots had been trained primarily using their own aircraft, honing tactics suited to engaging opponents with similar performance characteristics, flying the same type of aircraft, and utilizing doctrines developed from shared training experiences. This insular approach created a dangerous blind spot when facing Allied pilots flying different aircraft with varying capabilities, especially regarding range, high-altitude endurance, sustained speed, and tactical doctrines that exploited these specific advantages. Many Allied aircraft possessed distinct advantages in these areas, making German pilots vulnerable when engaging unfamiliar enemy machines. Recognizing this, the Germans prioritized improving their understanding of these aircraft through systematic testing and evaluation of captured enemy planes to develop better tactics and countermeasures. By the year of 1944, the German salvage operations for enemy aircraft had become highly organized and efficient. Specialized salvage units, operating across occupied territories under the authority of units such as Belgian Battalion or salvage battalions, worked tirelessly to locate, assess, and recover Allied aircraft. These teams swiftly secured crash sites, evaluated the extent of damage, and transported the repairable aircraft back to centralized testing and repair facilities before the advancing Allied forces could recapture them. This highly structured and systematic approach to capturing Analyzing and learning from enemy aircraft represented a critical element of the German war effort, providing vital intelligence and technological insights that could be exploited to improve their own aircraft designs, tactics, and overall combat effectiveness. The organization behind the German military operations reflected a meticulous and disciplined structure, a testament to their thorough approach even as the availability of resources became increasingly limited and scarce. This systematic and precise organization was a hallmark of their military culture, ensuring that every aspect of their operations was conducted with efficiency, order, and strategic foresight, despite the mounting logistical challenges faced during the later stages of the war. Given the immense scale of the Allied air campaigns over the European continent, the likelihood of aircraft being forced to land or crash in enemy-controlled territory was virtually unavoidable. The sheer volume of air sorties flown each month by the combined efforts of American and British forces, numbering in the thousands, meant that mechanical failures, combat-related damage, navigational mistakes, running out of fuel, or adverse weather conditions often resulted in pilots having to make emergency landings behind enemy lines. The probability of such incidents was compounded by the intensity and frequency of these military operations, making encounters with the German defenses inevitable. Not every aircraft involved in these emergency landings was completely destroyed or rendered unusable upon impact. Many pilots, faced with hopeless situations, managed to execute controlled crash landings, deliberate attempts to bring their planes down in a manner that minimized damage. These pilots aimed to preserve as much of their aircraft as possible, sometimes managing to leave their planes relatively intact, with only minor structural harm that could potentially be repaired using available tools and spare parts. Such salvageable aircraft could then be recovered, repaired, and put back into service, significantly boosting the Allied forces' resourcefulness amidst limited supplies. An illustrative example of this process is the case of Fraser's P-51 Mustang, marked B-15NA, which fell into the category of aircraft that could be repaired and reclaimed. During the fervent fighter sweeps supporting the D-Day landings, this particular aircraft sustained considerable damage, ultimately forcing the pilot to execute an emergency landing in territory still controlled by German forces, despite the ongoing invasion. Within hours, specialized German recovery teams arrived at the crash site, following well-established procedures for evaluating and handling crash incidents in enemy territory. The German teams carefully examined Fraser's Mustang, conducting a thorough assessment of the extent of the damage inflicted during the crash and combat. After detailed evaluation, they concluded that, despite the visible battle scars and the impact forces involved in the crash, the airframe itself remained sufficiently intact to warrant repairs. The decision was made to recover the aircraft for potential restoration, knowing that with the right resources and technical expertise, it could be brought back to a flightworthy condition. The aircraft was carefully loaded onto specialized transport equipment and transported to the Luftwaffe's primary testing and repair facility. Located near Lake Moritz, known as the Rechlin Testing Center. This facility, which had officially been designated as the Luftwaffe's Central Evaluation and Development Hub on the 26th of February, 1936, was equipped with extensive workshops filled with specialized tools, comprehensive test ranges, and runways designed explicitly for evaluation flights under controlled conditions. These facilities enabled German engineers and technicians to meticulously analyze the performance characteristics of captured enemy aircraft and assess their potential for repair, reverse engineering, and integration into their own fleet. At Rechlin, the technicians demonstrated impressive skill and resourcefulness in the repair and reconstruction of Allied aircraft, often working without original technical manuals, factory specifications, or authentic spare parts produced to original tolerances. Their expertise in reverse engineering was critical, especially given the scarcity of genuine components and documentation, which became more common as the war progressed and supplies grew increasingly limited. The process of repairing Fraser's Mustang was a testament to German technical ingenuity and adaptability. Mechanics and engineers resorted to cannibalizing parts from other wrecked P-51s recovered across Europe, assembling an inventory of usable components that could be fitted to rebuild a functioning aircraft. This patchwork approach involved meticulous matching of parts, innovative engineering solutions, and a deep understanding of aircraft systems, all aimed at creating a single aircraft capable of resuming flight. Among the various components, the engine played a pivotal role in restoring the aircraft's functionality. The engine used was a Packard V1650-3 Merlin, a license-built adaptation of the renowned Rolls-Royce Merlin 63. This engine featured a two-stage, two-speed supercharger, capable of producing approximately 1,490 horsepower at an altitude of 13,750 feet when operating with a boost pressure of 61 inches of mercury. The process of restoring and tuning such an engine was complex, but essential to return the aircraft to operational status and ensure it could perform reliably in future missions. The aircraft's engine, after undergoing a thorough inspection, was meticulously serviced and restored using replacement parts sourced from multiple suppliers to ensure optimal performance. This engine represented a remarkable milestone in aviation technology, capable of delivering significantly higher power output at high altitudes than traditional single-stage supercharged engines. Its advanced design featured a sophisticated intercooled two-stage supercharger system, which effectively enhanced power and efficiency under demanding conditions, demonstrating the engineer's ingenuity and mastery. In terms of armament, the P-51B variant initially mounted two lethal 50 caliber Browning M2 machine guns on each wing, arranged in a configuration typical for American fighters of the time. However, during the inspection process, these weapons were removed, and the aircraft was equipped instead with ballast weights. This adjustment was necessary to preserve the aircraft's proper weight balance and center of gravity. Such modifications were mandated by strict German regulations, which forbade the armament of captured aircraft deployed for testing or demonstration purposes, primarily to mitigate security risks and prevent adversaries from gaining intelligence or potentially repurposing the aircraft against German forces. The control surfaces, including elevators, ailerons, and rudders, were subjected to rigorous evaluation to confirm their structural integrity and seamless operation. Hydraulic systems, crucial for controlling these surfaces, were pressurized and carefully checked for leaks, ensuring reliable responsiveness during flight. Fuel tanks within the aircraft were scrutinized meticulously for any signs of damage, cracks, or leaks that could potentially lead to catastrophic failures in flight. Special attention was given to identifying weak points that might compromise safety during operational use. The iconic Razorback canopy, a distinctive feature of the P-51B, was preserved and repaired with great care. While the German engineers maintained the original design, they also noted some limitations, particularly in rearward visibility, which was more restricted compared to the later P-51D's bubble canopy. The latter offered unobstructed views, greatly enhancing pilot situational awareness. Despite these constraints, the canopy's preservation was vital for maintaining the aircraft's aerodynamic profile and structural integrity during testing. Following weeks of diligent effort by skilled technicians working under resource constraints and often improvising solutions, the aircraft was declared ready for its initial flight tests. German test pilots, approaching their first encounters with this captured American fighter, brought a blend of professional curiosity and a healthy dose of skepticism, rooted in years of Luftwaffe propaganda portraying American aircraft as mass-produced, less refined machines. Official German narratives had long depicted American aircraft as devices prioritized for quantity over quality, emphasizing simplicity and ease of manufacturing rather than advanced engineering and performance. Many German pilots and authorities believed that American design philosophy aimed merely to produce a sufficient number of acceptable aircraft rather than pushing the boundaries of aeronautical innovation. Such assumptions persisted despite observable differences in aircraft capabilities and engineering sophistication. However, these comfortable beliefs began to unravel as soon as experienced German test pilots climbed into the cockpit of the Mustang and experienced firsthand the engineering excellence and meticulous design that American engineers had achieved. They quickly recognized that the aircraft was not merely a mass-produced machine but a product of careful planning, sophisticated engineering, and a focus on operational efficiency, a stark contrast to the stereotypes they had previously held. The cockpit of the P-51B immediately left a strong impression on these pilots, especially when compared to the cramped confines of the Messerschmitt Bf 109 cockpit or even the roomier but less sophisticated Fowler-Wolf FW 190. The Mustang's interior showcased a thoughtful ergonomic layout, with controls logically arranged and positioned for quick, intuitive operation. This design significantly reduced pilot workload and enhanced situational awareness, enabling pilots to concentrate on flying and combat tactics rather than struggling with unfamiliar or poorly arranged controls. Focusing predominantly on tactical scenarios rather than wrestling with the complexities of aircraft systems, pilots found themselves better able to devote their attention to the strategic aspects of combat. The cockpit instrumentation was thoughtfully designed, with gauges that were not only clearly marked but also organized in a logical manner that facilitated rapid comprehension and response. This arrangement adhered to human factors principles that emphasized maximizing pilot efficiency and reducing cognitive load, especially crucial during the high-stakes, fast-paced environment of aerial combat. The pilot's seat offered markedly superior comfort when compared to the more Spartan seating arrangements typical of contemporary German fighters. This enhanced ergonomic support was especially important during extended missions, where fatigue could impair a pilot's decision-making and aircraft handling capabilities. By reducing the physical strain, the seat contributed indirectly to maintaining situational awareness and combat effectiveness over long periods in the air. Visibility from the cockpit was another major advantage of the aircraft's design. Even in the earlier Razorback configuration, which featured a framed canopy, pilots enjoyed a significantly improved field of view compared to the heavily framed canopies of the Messerschmitt Bf 109. German pilots faced limitations such as restricted sight lines and, notably, poor rearward visibility, leaving them more vulnerable to attack from behind. In stark contrast, the clearer canopy of the Mustang allowed pilots to maintain better situational awareness, which was a critical factor in dogfights. However, the most striking revelation arose when German test pilots applied full throttle and experienced the response of the Packard V1650-7 Merlin engine. They were struck by how smoothly and progressively the engine delivered power, responding to throttle inputs with an almost seamless rise in thrust. This responsiveness was a key feature, allowing pilots to precisely modulate engine power during combat, whether for aggressive pursuits, defensive maneuvers, or rapid climbs. As the aircraft accelerated down Recklin's runway, the power built in a steady, predictable manner, giving the impression of a well-engineered balance between engine capability and aerodynamic efficiency. The four-bladed Hamilton standard propeller efficiently bit into the air, translating engine power into forward motion with remarkable effectiveness. The takeoff roll was noticeably shorter than one might expect for an aircraft of the P-51's substantial weight and size, underscoring the outstanding combination of power, weight distribution, and aerodynamic refinement. This efficiency was a clear testament to the engine's high power output and the aircraft's streamlined design, which minimized drag through the entire speed range. Once airborne, the Mustang's handling qualities further challenged preconceived notions held by German pilots about American aircraft. The aircraft exhibited a responsiveness and agility that were almost revolutionary for its class. The flight controls, aileron, elevator, and rudder, demonstrated a harmonious balance, offering a consistent feel across all speeds, from slow approach velocities to maximum velocity. Control forces scaled predictably with speed, providing pilots with solid feedback, while at lower speeds, they eased smoothly into more sensitive and manageable inputs. The aircraft responded with crispness and predictability to control inputs, avoiding the oversensitivity or twitchiness that had plagued some other fighters. Its roll rate was notably superior to that of the Bf-109 and approached the exceptional turning capabilities of the FW-190. Such agility enabled pilots to execute rapid changes in flight direction, a critical advantage in dogfighting, allowing them to outmaneuver opponents or position themselves advantageously for attack or defense. Moreover, the aircraft could be subjected to aggressive maneuvers without exhibiting tendencies toward uncontrollable departure, spins, or other hazardous behaviors that could prove disastrous in combat. German test pilots systematically explored the Mustang's performance envelope through carefully planned flight tests, executing a series of standardized maneuvers designed to reveal its strengths, limitations, and any underlying risks. These evaluations confirmed that the aircraft was robust and reliable, capable of enduring the stresses of combat maneuvers. Of particular interest was the aircraft's climb performance, which left German pilots impressed and somewhat apprehensive. The P-51B demonstrated exceptional climb rates, maintaining high performance at altitudes well above those typically achievable by contemporary fighters. This ability to ascend quickly had profound tactical implications, providing advantages in gaining altitude for defensive or offensive purposes, thereby shaping the perceived strategic value of the aircraft in aerial combat scenarios. Flying at altitudes reaching 30,000 feet, the twin-stage supercharged Merlin engine of the P-51 Mustang continued to produce impressive amounts of power. While the engine maintained its robust performance, the increasingly rarefied atmosphere at such heights significantly hampered the capabilities of German fighters equipped with single-stage superchargers. These fighters, which relied on a simpler, single-stage setup, struggled to generate sufficient airflow into their engines as they ascended into the thinner air, leading to a marked decline in their operational effectiveness. Particularly for German pilots and strategic planners, the aircraft's high-altitude capabilities became a matter of considerable concern. American bomber formations often operated within an altitude range roughly between 25,000 and 30,000 feet, a zone characterized by cold, thin air. At these heights, the protection offered by defensive firepower from the bombers remained potent, especially against fighters that had to slow down significantly to attack. However, German fighters with single-stage superchargers faced mounting difficulties because their engines couldn't perform efficiently under these conditions. They found themselves increasingly hampered by the thin atmosphere, which diminished engine power and hampered agility, thus making it harder to intercept or effectively engage the bombers. In stark contrast, the P-51's advanced two-stage Merlin engine provided consistent, reliable power even at these lofty heights. This technological advantage proved to be a game-changer. Pilots soon recognized that the Mustang could not only escort bombers successfully at these high altitudes but also engage in combat effectively there. The aircraft maintained a superior speed advantage and superior maneuverability, while German fighters, hampered by reduced engine power in the high-altitude environment, found it progressively harder to keep pace or mount effective attacks. Their engines, strained against the sparse air, forced their aircraft into slower speeds and degraded handling characteristics. Controlled speed tests conducted at various altitudes further confirmed the Mustang's dominance in this crucial performance aspect. Under ideal conditions, the P-51B was capable of reaching speeds of approximately 440 miles per hour at its optimal altitude, with the engine running at military power settings. This was notably faster than the German Messerschmitt Bf 109G, which could reach about 386 miles per hour under similar conditions, and the Focke-Wulf FW 190A, which, when measured under comparable circumstances, achieved only around 480 miles per hour. This notable speed advantage translated directly into tactical flexibility and superiority in aerial combat. Mustang pilots gained the ability to control the terms of engagement, choosing when to attack and when to retreat. They could pursue retreating German fighters with an element of speed and confidence, knowing that their aircraft's higher velocity allowed them to close the distance quickly. Conversely, if faced with a numerically superior or more aggressive enemy, they had the option to disengage, accelerating away from slower German aircraft that lacked the necessary speed to pursue, or to avoid prolonged combat, thus conserving their strength. German pilots soon discovered that they could not force a confrontation when the Mustang pilot, recognizing an unfavorable situation, chose to disengage. This strategic advantage fundamentally limited German tactical options, as their fighters could no longer reliably force engagements on their terms. The Mustang's sleek aerodynamic design, built upon the principles of laminar flow airfoil sections developed by the National Advisory Committee for Aeronautics, NACA, contributed significantly to this advantage. Its distinctive appearance was not merely aesthetic but indicated a focus on aerodynamic efficiency, which translated into high speed, good handling, and extended range. Although German engineers noted that achieving ideal laminar flow in operational conditions was more difficult than initially believed, mainly due to manufacturing tolerances, surface imperfections, rivets, paint, and wear, the aerodynamic improvements in the Mustang's wing design still delivered remarkable benefits. Despite these challenges, the wing generated a substantial amount of lift with minimal drag, far surpassing conventional airfoil designs. This efficiency played a critical role in extending the aircraft's range and improving its fuel economy, allowing the P-51 to escort bombers deep into enemy territory without requiring frequent fuel stops. The effectiveness of the Mustang's wing design remained consistent across a wide spectrum of speeds. It maintained excellent handling characteristics during landing, takeoff, and low-speed maneuvering, while also supporting high-speed flight. The aerodynamic benefits of the laminar flow wing contributed to the aircraft's reputation as one of the most capable and versatile fighters of the war, giving its pilots a significant tactical edge over less aerodynamically refined German aircraft. The P-51 Mustang exhibited exceptional high-speed handling capabilities during combat maneuvers, consistently delivering predictable and stable flight characteristics that significantly alleviated pilot workload while enhancing overall combat effectiveness. Its ability to maintain stable control at elevated speeds provided pilots with a reliable platform to execute complex tactical maneuvers, thereby increasing their chances of success in high-intensity engagements. One of the most notable aspects of the Mustang's performance was its remarkable dive ability. When subjected to steep dives reaching very high velocities, the aircraft demonstrated a clear advantage over many German fighters of the era. Unlike other aircraft that often experienced severe control stiffening or a dramatic reduction in maneuverability near their design speed limits, the Mustang could endure these high-velocity dives without sacrificing control authority. This meant that pilots could pull out of these steep, high-speed descents effortlessly, exerting minimal physical effort and fighting little against unresponsive or locked controls. Throughout such maneuvers, the airframe remained notably stable, with no signs of fluttering, buffeting, or structural compromise, ensuring safety and reliability even in the most demanding situations. German test pilots observed and noted this exceptional dive stability with particular interest and concern. Since the German tactical doctrine heavily relied on diving attacks, approaching from altitude to rapidly build up speed and energy before pulling away, the Mustang's capacity to perform such maneuvers without losing control posed a significant challenge to their tactics. The ability of the P-51 to follow German fighters through high-speed dives while maintaining full control underscored the aircraft's superiority and threatened to negate the German advantage in energy tactics. Turning performance, however, presented a more layered and complex picture. At moderate speeds and in level flight, the P-51 could not quite match the sustained turn rate of the Messerschmitt Bf 109, particularly because the German fighter employed leading-edge slats that automatically deployed during high-angle of attack maneuvers. These slats delayed wing stall onset during tight turns, providing the Bf 109 with a distinct edge at moderate, sustained turning engagements. At medium altitudes and slower speeds, the smaller, more agile Bf 109 enjoyed advantages in turn radius and turn rate, allowing it to fight in a more confined turning circle. Nonetheless, through extensive systematic testing and simulated combat scenarios, German pilots learned that the Mustang's superiority in speed, climb rate, and overall energy management allowed skilled pilots to avoid prolonged turning fights altogether. Instead, pilots could use the Mustang's excellent energy conversion capabilities, transforming speed into altitude and vice versa, to control the fight on their own terms. This energy tactic capability meant Mustang pilots could quickly gain altitude after a high-speed pass, reposition, and then accelerate again, thereby maintaining a high-energy state throughout combat. Such tactics enabled them to engage when conditions were advantageous and to disengage if the situation turned unfavorable, thereby rejecting the German fighters' preferred combat geometry and forcing the Germans into less advantageous positions. The strength of the Mustang's construction also left a strong impression on German engineers who examined this aircraft in meticulous detail, both at the Rechlin factory and during evaluations at Göttingen. These inspections revealed that the P-51 was built with a significantly robust structural framework, incorporating considerable safety margins into its critical structural components. Its airframe was designed to withstand more stress and battle damage than might be expected, providing an extra level of resilience in combat. This emphasis on durability contrasted sharply with typical German design philosophies, which often prioritized minimal weight and maximal performance at the expense of structural robustness. German aircraft engineers frequently pushed their aircraft structures to the absolute limits, sacrificing some margin of safety in the pursuit of higher performance levels. In comparison, the P-51's resilient construction meant it could absorb considerable battle damage that would have severely compromised lighter German fighters, allowing it to remain operational longer and sustain more damage during combat encounters. In summary, the Mustang's combination of high-speed stability, exceptional climb, and energy management tactics, along with its sturdy construction, made it a formidable opponent that challenged and often outperformed German fighters in various facets of aerial combat. This aircraft's design philosophy, emphasizing robustness and reliable handling, contributed significantly to its effectiveness in the skies, providing U.S. pilots with a decisive advantage in many encounters. During combat operations, the resilient construction of the aircraft often enabled it to sustain damage and still make successful returns to base, a crucial trait that directly contributed to higher pilot survival rates and ensured that more aircraft remained available for subsequent missions. This focus on durability and survivability was a fundamental aspect of American engineering philosophy, which deliberately prioritized these qualities even if it meant accepting a somewhat increased empty weight. Such a design approach valued the aircraft's ability to endure the rigors of combat and prolonged operations, ultimately keeping both pilots and aircraft in the fight for longer periods. The remarkable range of these fighters, especially the P-51B model, left German pilots thoroughly astonished. Unlike their own fighters, such as the Bf-109 or Fw-190, that rarely exceeded 90 minutes of total flight time, including any combat engagements, the Mustang could carry significantly more fuel internally. Its aerodynamically efficient wing design allowed this increased fuel capacity to translate into an extraordinary operational radius, which seemed almost unbelievable to the German pilots, who had become accustomed to their fighters' limited endurance. When external drop tanks were attached beneath the wings, the Mustang's range expanded further, enabling it to undertake missions lasting more than 8 hours. From a tactical perspective, this tremendous endurance allowed fighters to cover vast operational distances that German pilots found difficult to comprehend. Their fighters' combat radius barely surpassed 200 miles under ideal conditions. Such a substantial range advantage transformed the nature of bomber escort missions and had profoundly strategic implications. Prior to the arrival of the Mustang, German fighters often exploited their shorter-range aircraft by waiting patiently until their Allied counterparts' escorts exhausted their fuel supplies and then turning back to their bases. During this window, they could strike undefended bombers, especially during the most perilous stages of their deep invasion missions into German-held territory. The introduction of the Mustang effectively closed this tactical vulnerability. American escort fighters could now accompany bombers throughout the entire duration of deep missions into Germany and safely return all the way to England, thereby denying German fighters any opportunity to attack unprotected targets at the most critical moments. This shift in tactics had significant strategic consequences. German Luftwaffe commanders recognized that their fighters could no longer simply wait for vulnerable moments, as they now had to penetrate the full escort screen to reach the bombers. Consequently, German pilots faced considerably higher risks on each interception sortie, often having to fight through formidable Allied escort forces before even getting close to their targets. German pilots who had the rare opportunity to fly captured Mustangs during test flights and simulated combat consistently expressed their deep admiration for the aircraft's handling characteristics and overall ease of operation. Unlike some aircraft that demanded excessive physical strength or delicate precision, the Mustang's flight controls provided a balanced feel that did not require overly forceful inputs. This harmonious control layout enabled pilots to fly with both aggressive intent and precise accuracy without fear of over-controlling or inadvertently losing control during rapid or violent maneuvers. Such forgiving handling meant that the average pilot could extract solid performance in most combat situations, and highly skilled pilots could push the aircraft's capabilities to achieve exceptional results. Maintenance and accessibility were additional areas where the Mustang surpassed expectations, especially compared to German fighters like the Bf-109 and Fw-190, which were notorious for their sometimes extraordinarily difficult servicing requirements, particularly when performed under field conditions with limited ground support equipment. The Mustang's engine cowling was designed to open in multiple sections, granting excellent access to the Merlin engine and its associated systems. This modular approach to engine maintenance significantly simplified repairs and routine servicing, allowing ground crews to work more efficiently even under challenging circumstances, thus enhancing aircraft availability and operational readiness. In sum, the combination of its resilience, extraordinary range, ease of handling, and maintenance advantages made the Mustang a game-changing fighter in the Allied arsenal. Its design not only improved the survivability of pilots and aircraft but also fundamentally altered the tactical landscape of aerial combat over Europe during the war. Aircraft, such as the renowned Mustang, were showcased in intense simulated battles designed to provide German pilots with first-hand insight into the capabilities and tactics of their adversaries. These sessions were more than mere demonstrations. They served as immersive educational experiences, offering a rare opportunity for German fighter pilots to observe and understand the operational strengths and potential vulnerabilities of enemy aircraft in a controlled environment. Throughout these exhibitions, the captured Mustangs, particularly those designated with the codes TN9+HK, were subjected to rigorous inspections and lively aerial performances that highlighted their advanced engineering and tactical advantages. The aircraft's design reflected meticulous American engineering priorities, emphasizing ease of maintenance and rapid turnaround times. Their construction incorporated numerous accessible panels distributed across the airframe, which could be swiftly removed to facilitate inspections, repairs, or adjustments inside the aircraft. This thoughtful layout underscored the American philosophy that minimizing downtime was crucial, as aircraft that remained grounded awaiting repairs contributed little to the overall fighting capacity, regardless of their potential performance in excellent condition. During the late months of 1944, Rosarius and his team conducted extensive tours across various Luftwaffe fighter stations scattered throughout Germany. These visits involved a systematic approach, establishing temporary operations at each location, setting up fully equipped demonstration areas, and presenting comprehensive exhibitions of the Mustang's capabilities. German pilots, ground crew, and military officials were given a detailed, up-close look at the aircraft, with demonstrations showcasing both its raw speed and agility. These displays were not only technical presentations but also strategic lessons, aimed at educating German pilots on how to adapt their tactics against the formidable American fighter. The process typically began with a striking visual element. The captured aircraft, painted in bright hues with familiar markings, taxied past a gathering of German personnel, creating a scene that was almost surreal. The sight of enemy aircraft with German insignia moving among German fighters was a stark reminder of the technological and tactical gaps. Seeing these aircraft up close, examining their construction, understanding their layout, had a profound psychological effect on the German observers, transforming the enemy from an abstract threat into a tangible, real opponent. Following these ground displays, the aircraft would take to the skies for a series of flight demonstrations. Highly skilled German test pilots, many of them experienced in evaluating foreign aircraft, would fly the captured Mustangs through a series of carefully choreographed aerobatic routines and tactical maneuvers. These aerial demonstrations were far more effective than any written report or verbal brief could be, as they vividly showcased the aircraft's real-world performance. In these flight routines, the pilots would perform high-speed passes at low altitude, emphasizing the Mustang's extraordinary velocity, which far exceeded that of German fighters. Demonstrations of climbing ability involved soaring to altitudes surpassing 30,000 feet, highlighting the aircraft's remarkable high-altitude performance, made possible by its sophisticated two-stage supercharged engine. The pilots also executed precise rolls and banked turns, illustrating the Mustang's agile handling and rapid directional changes, essential qualities in dogfighting. Mock dogfights formed a core part of these demonstrations, pitting the captured aircraft against German fighters in simulated combat scenarios. These exercises vividly illustrated both the advantages of the Mustang and the conditions under which German fighters might still hold an edge. Observing the aircraft's acceleration, maneuverability, and firepower in action helped German pilots understand how to exploit the Mustang's weaknesses and adapt their tactics accordingly. After the flying demonstrations, the aircraft would often remain on the ground for detailed examinations. German pilots, ground personnel, and engineers had the opportunity to approach the aircraft directly, inspect its instrumentation, and scrutinize its cockpit layout. They could pose questions directly to the pilots who had flown the plane, gaining invaluable insights through discussions that clarified the aircraft's operational characteristics and maintenance requirements. These visits, especially the live tactical demonstrations and detailed inspections, proved to be one of the most effective methods of closing the knowledge gap between the two air forces. They provided German pilots with a concrete understanding of the enemy's technological edge and tactical approaches, which, in turn, could inform their own training and combat strategies. The ultimate goal was to understand the enemy better, gain insights into the strengths of Allied aircraft like the Mustang, and develop new tactics to counter their advantages, an invaluable effort in the relentless pursuit of air superiority during the final phases of the war. Throughout late 1944, as Allied bomber operations grew more intense and German aircraft losses mounted steadily, a series of highly instructive and revealing mock combat demonstrations took place at various Luftwaffe airfields. These exercises were meticulously designed to engage experienced German pilots in controlled, yet realistic simulated battles, carefully monitored by knowledgeable observers. The core purpose was to give these pilots a clear, first-hand understanding of how Allied fighters, particularly the P-51 Mustang, performed and to analyze the effectiveness of their own tactics and aircraft against such formidable opponents. At one such pivotal demonstration, held at an airfield where the unit Jägerschade 1 was based, a select group of seasoned German pilots was tasked with flying their own operational aircraft while engaging in mock combat against captured Allied types, notably the P-51 Mustang. The goal was to acquire practical, operational insights, knowledge that could be communicated to their squadron colleagues, by experiencing actual combat scenarios from both sides. During this exercise, a skilled German test pilot took the cockpit of a captured P-51 Mustang, deliberately demonstrating tactical approaches that American pilots had perfected and routinely employed in real combat situations. The demonstration showcased the Mustang's clear advantages in terms of speed and climbing ability. The American pilot deftly used these superior performance characteristics to maintain energy, avoid dangerous turning battles, and dictate the terms of engagement. The Mustang's agility in managing its speed and altitude allowed it to stay out of reach while striking decisively when opportunities presented themselves, illustrating the crucial importance of energy management in aerial combat. Meanwhile, German pilots flying Messerschmitt Bf 109 gigaseconds and Focke-Wulf FW-190s attempted to confront the Mustang by applying standard Luftwaffe tactics that had historically proved effective against earlier Allied fighters. These tactics relied heavily on aggressive pursuit and close-quarters turning engagements, aiming to neutralize enemy speed advantages through superior maneuverability. However, they quickly encountered the daunting reality. Engaging a well-trained Mustang pilot who was expertly managing energy and exploiting aircraft strengths proved exceedingly difficult. Whenever German pilots pushed aggressively in pursuit, the Mustang would accelerate away, increasing distance faster than the Germans could close in. Attempts to climb above the P-51 for diving attacks were thwarted as the Mustang outclimbed them, reaching higher altitudes first and reversing the tactical situation to the advantage of the American aircraft. Furthermore, when the Germans tried to force a prolonged turning dogfight, assuming the Bf-109's better maneuverability would give them an edge, the Mustang pilot would simply refuse the fight, extending away with superior speed, then turning the tables when conditions favored an attack, often re-engaging with a renewed energy advantage. These mock combat exercises delivered a sobering message to the German pilots. Many had believed or hoped that their aircraft and established tactics remained competitively viable despite the deteriorating overall strategic situation faced by Germany. But, witnessing the Mustang's incredible performance capabilities in a dynamic, controlled combat setting laid bare the stark reality. Allied pilots flying P-51s possessed considerable tactical advantages, particularly at the high altitudes where much of the bomber escort missions took place. Repeatedly, across numerous Luftwaffe bases, the pattern of harsh but enlightening revelations persisted. The demonstrations, conducted under the auspices of the Wonder Zirkus Rosarius, conveyed a clear, unambiguous message concerning the shifting aerial combat landscape. From late 1944 into the early months of 1945, these sessions progressively underscored the growing disparity in aircraft performance and tactical effectiveness, profoundly influencing German pilots' understanding of their capabilities versus those of their Allied opponents. Initially, German pilots had been reassured by official assurances that their fighters remained competitive or at least on par with Allied aircraft. These claims were often repeated during pre-demonstration briefings, designed to bolster morale and confidence. Yet, as the demonstration sessions unfolded, it became undeniable that the sleek, high-performance P-51 Mustang surpassing their aircraft in key performance metrics was drastically changing the nature of aerial combat, highlighting the importance of energy management and tactical flexibility, areas where the Mustang's design and American training excelled, thus exposing the vulnerabilities of the older German fighter types. To deepen German pilots' understanding of their enemies, revealing the true strength, agility, and tactics of Allied fighters, which often contrasted sharply with the overly optimistic reports propagated by propaganda and official briefings. These first-hand demonstrations, involving the examination and mock combat use of captured aircraft, provided concrete and irrefutable evidence that German fighters faced highly capable opponents whose combat effectiveness often exceeded expectations. Walter de Hall, who was in charge of fighter units during the year 1944, later recounted in his memoir the visits of the so-called Wonder Zirkus Rosarius to his bases. However, modern historians approach his accounts with some caution, as his narrative has been noted for issues with accuracy and reliability throughout his writings. Despite this, his descriptions paint a vivid picture of what occurred during these clandestine aerial exchanges. He vividly described how captured American fighters would arrive alongside enemy heavy bombers, an unusual sight that seemed almost surreal, where German pilots could observe these aircraft closely, often parked side by side with their own machines. This practice created opportunities for formation leaders to fly captured enemy aircraft in controlled mock battles. Such exercises allowed German pilots to experience the handling, speed, and tactical nuances of Allied fighters firsthand, rather than relying solely on second-hand intelligence or official reports, which could often be exaggerated or outdated. Dahl emphasized that this kind of training was immensely valuable because it provided a realistic understanding of the enemy's capabilities, an insight that could be decisive in aerial combat, where rapid, split-second decisions often determined the outcome of a dogfight. Following these demonstration flights, flight commanders would conduct detailed instructional sessions with their squadron members. They shared tactical insights gleaned from their personal observations and direct experience flying these captured aircraft, often including specific recommendations for engagement strategies. This systematic transfer of knowledge helped German pilots to develop a more nuanced understanding of Allied aircraft, including their strengths, weaknesses, and operational tactics. Nevertheless, by late 1944, the benefits of this program were increasingly limited, as Germany's overall strategic situation was rapidly deteriorating across all fronts. While these demonstrations undoubtedly provided valuable tactical intelligence and helped to refine German pilots' understanding of their adversaries' equipment, they could not offset the fundamental disadvantages facing the Luftwaffe. The German Air Force was plagued by chronic fuel shortages, which worsened over time and severely restricted the amount of flight training that could be provided to new pilots. As a result, many freshly trained pilots were sent into combat with minimal experience, often ill-prepared to face the more agile and well-coordinated Allied fighters. Veteran pilots, who had managed to survive the relentless attrition of the 1944 air battles, where German fighter pilot losses reached levels that were increasingly unsustainable, became an even scarcer resource. Many of these experienced pilots had learned through hard, often fatal combat encounters how to effectively counter aircraft like the American P-51 Mustang, which had become a formidable adversary. Aircraft production levels, while surprisingly high considering the ongoing Allied strategic bombing campaigns targeting German industry, could not rapidly replace the losses taken in combat. The continuous attrition of experienced pilots and aircraft meant that the Luftwaffe's overall combat effectiveness steadily declined, despite the efforts to leverage captured technology and intelligence. Most critically, although the revelations gained from examining and flying captured Allied aircraft added a layer of tactical knowledge, this advantage proved increasingly insufficient as the war dragged on. The core issues of fuel shortages, dwindling pilot experience, and mounting aircraft losses meant that the German force's ability to effectively utilize this intelligence was severely hampered. The reconnaissance and training programs helped to deepen understanding but could not reverse the harsh reality that, by the latter part of 1944, the Luftwaffe was fighting a losing battle against both the Allies' overwhelming industrial and military might and its own internal shortages and attrition. The realization that their aircraft were inevitably inferior in key performance aspects began to profoundly demoralize German pilots, rather than serve as a source of inspiration. As the war progressed, these aviators increasingly understood that they commanded aircraft that either lacked the capability of the American fighters or at least fell significantly short in the most critical performance parameters for their assigned missions. In particular, the P-51 Mustang's remarkable speed, exceptional range, and outstanding high-altitude performance stood unmatched by any of the German fighters that were operational at the time. These advantages rendered German aircraft not only less effective but also increasingly obsolete in the evolving aerial combat environment. The intelligence gathered from the interception and capture of Mustangs went far beyond simple flight tests or combat assessments. German engineers, both at Rechlin and Göttingen, conducted thorough disassemblies of captured aircraft components, aiming to decipher the sophisticated manufacturing processes, material choices, and intricate design philosophies employed by the American engineers. In their detailed examinations, they scrutinized the Mustang's wing structure and airfoil sections with meticulous care. Their goal was to understand the construction techniques and aerodynamic principles that enabled the American designers to produce such remarkably efficient performance. The analysis extended to the Packard V1650-3 Merlin engine, which featured a sophisticated two-stage supercharger system equipped with an intercooler, an innovation that greatly contributed to its outstanding high-altitude capabilities. Special attention was also given to the Mustang's fuel system, as German engineers sought to comprehend how the American engineers managed to achieve such an impressive operational range, often spanning thousands of miles. The evaluation of hydraulic systems revealed a focus on their reliability and straightforward maintenance procedures, which contrasted with the challenges faced by German systems of similar complexity. Throughout their investigations, German experts repeatedly noted the superior quality of materials used throughout the American aircraft, emphasizing the consistency and excellence in their construction. The strategic advantage of access to high-quality materials, such as specialized aluminum alloys, robust steels, and durable rubber compounds, enabled American designers to craft structures that balanced strength, lightness, and manufacturability. These materials allowed for the production of aircraft that maximized performance without excessive weight, all while maintaining efficient mass production. In contrast, by 1944, Germany faced severe shortages of such critical materials, forcing the adoption of substitutes that often proved inferior in strength, durability, or manufacturability. The captured Mustang revealed manufacturing techniques that exemplified the American approach to mass production, methods that maintained high standards of quality without sacrificing speed. American factories employed advanced assembly line processes, which ensured tight tolerances and consistent quality across thousands of individual aircraft, making the P-51 a reliable and high-performing addition to their air fleets. Meanwhile, German aircraft production grew increasingly fragmented, relying on numerous smaller facilities scattered across the country. This dispersed manufacturing network was a deliberate response to Allied bombing campaigns, but it often meant that quality control suffered, especially when some of the work was carried out with inadequately trained forced labor. As a result, the quality of German aircraft became inconsistent, maintenance issues grew more frequent, and operational aircraft often faced reduced reliability and performance. The specific captured Mustang, designated T9+HK, was assigned to the Wonder Zirkus Rosarius, a unit known for showcasing aircraft capabilities and performances. Unfortunately, on December 10 of the year 1944, this aircraft, along with its pilot Oberleutnant Liebschens, was lost, though the precise circumstances surrounding the loss remain unclear. Some historical records suggest that the aircraft may have crashed during a demonstration flight, or perhaps was destroyed in an incident, but definitive details are scarce, leaving the exact cause of the aircraft's demise uncertain. During the era of intense aerial conflict, many American fighter aircraft, particularly the renowned P-51 Mustang, found themselves not only engaged in combat but also subjected to capture and evaluation by their adversaries. Some of these aircraft were lost during aerial dogfights, either shot down during fierce battles over enemy territory or destroyed in ground-based incidents such as crashes and bombings, especially when they were stationed at strategic airfields under threat. Others fell prey to the unpredictable circumstances of war, accidents, mechanical failures leading to forced landings, or reconnaissance missions that ended unexpectedly. By the time these planes completed their second operational lifespan, they had traversed vast swaths of German airspace, effectively becoming flying testaments and educational tools for the Luftwaffe. Throughout this phase, these captured Mustangs, which in a sense served as trophies and invaluable lessons, were flown across numerous Luftwaffe bases. They provided direct, hands-on training opportunities for hundreds of German pilots, exposing them to the American aircraft's design, performance characteristics, and tactical advantages firsthand. This close examination allowed German pilots and engineers to gain critical insights into the capabilities of the Mustang, insights that were otherwise difficult to obtain through reconnaissance or second-hand reports alone. Such practical exposure was considered an essential part of the Luftwaffe's efforts to understand and counter the growing threat posed by Allied air power. Historical records reveal that at least 2 of these captured P-51 Mustangs operationally served under the auspices of the Wonder Zirkus Rosarius, a special unit dedicated to utilizing captured enemy aircraft for evaluation, demonstration, and training purposes. These aircraft bore the Luftwaffe codes TN9+CK and TN9+HK at various points during the years 1944 and 1945. These designations signified specific operational roles assigned to them, often involving testing, training, or propaganda displays aimed at showcasing German adaptability and resourcefulness in exploiting enemy technology. It is worth noting that some historical sources have inaccurately listed additional aircraft, such as those coded TN9+FK and TN9+PK, as belonging to this same unit. However, meticulous research into wartime documents and post-war investigations clarifies this misconception. Evidence shows that the aircraft coded TN9+FK was actually a captured P-47D Thunderbolt, a different American fighter aircraft, while TN9+PK was identified as a captured Soviet Lavochkin La-5FN, a fighter of Russian origin. Furthermore, the TN9 designation itself was not officially assigned within the Luftwaffe's organizational records to any known operational grouping. Its presence strongly suggests it was merely an ad hoc code assigned, likely for operational convenience, to aircraft captured for specific missions or evaluations, rather than being part of the standard organizational hierarchy of the Luftwaffe. One particularly notable example of utilizing captured aircraft involved a P-51B Mustang, which was stationed at the Neuruppin airfield, located roughly 60 kilometers northwest of Berlin. This aircraft was used as a training tool for Hungarian fighter pilots, with the primary goal of developing and refining tactics for engaging the American Mustangs effectively. The training program focused on identifying and exploiting the limited tactical advantages that German fighters, such as the Focke-Wulf FW-190, still maintained against the Mustang, especially in particular combat scenarios. For example, Hungarian pilots learned to maximize their aircraft's strengths in sustainably turning at lower speeds and altitudes, tactics suited to close-range dogfights where maneuverability could neutralize the Mustang's superior speed and climb rate. Crucially, these training exercises also emphasized the importance of avoiding situations that played directly into the Mustang's overwhelming strengths, namely, high-speed pursuits, rapid climbs, and engagements at high altitudes. By understanding and exploiting the limited windows in which German and Hungarian fighters could challenge the American aircraft effectively, pilots hoped to raise their chances of survival and success in combat. Beyond immediate tactical applications, the broader implications of these experiences were profound. German pilots who underwent such training and evaluation gained a direct, tangible understanding of the Mustang's formidable capabilities that symbolized the advanced industrial and technical prowess of the United States. The Mustang's performance and design convincingly demonstrated that American industrial and engineering achievements were on par with or even surpassed those of Germany in critical areas, an uncomfortable realization that challenged long-standing propaganda claims of American technological inferiority. This recognition struck at the very heart of German wartime morale, which had long been rooted in the belief that German engineering and innovation were unrivaled. As pilots became increasingly aware of the Mustang's dominance in speed, altitude, and endurance, morale among German airmen faced a notable decline. The understanding that they were fighting against an aircraft that a well-trained opponent could exploit and that their own technological edge was diminishing weighed heavily on their confidence, despite individual skill, bravery, or tactical ingenuity. German commanders in particular were disturbed by the Mustang's impressive range capabilities, which presented a strategic challenge beyond the immediate tactical combat zone. The aircraft's extensive operational radius allowed American fighters to patrol vast distances, strike deep into German-held. The strategic landscape of the air war over Germany underwent a profound transformation as the Allies gained technological and tactical advantages that rendered German defenses increasingly ineffective. In the earlier phases of the conflict, the German Luftwaffe had been able to mount intercepts against Allied bombing raids with a reasonable chance of success, primarily because their fighters could patiently wait for the bombers to emerge from the cloud cover and then intercept them before the escort fighters, limited in number and range, had the opportunity to arrive on the scene. During these initial periods, Allied bombers often faced significant threats, but the situation gradually shifted as technological innovations changed the balance. The decisive breakthrough came with the introduction of the North American P-51 Mustang, which was actively used as an escort aircraft. When Mustangs achieved the capability to accompany bombing missions from takeoff to landing, it marked a turning point in the air war. This advancement made the bomber campaign effectively unstoppable because German fighters could no longer rely on waiting for escort fighters to turn back due to fuel constraints. Instead, they had to contend with an ever-present, well-protected formation of Allied fighters throughout the entire operation, greatly increasing the danger they faced. Interceptions that might have previously succeeded under the old constraints became nearly impossible, as German pilots had to fight their way through layers of heavily armed and well-coordinated escort fighters eager to defend the bombers. This shift was reflected not only tactically but also in the industrial capacity and logistics behind the aircraft production. By late 1944, American factories were churning out approximately 500 P-51s each month, a figure that kept climbing steadily. By January of the following year, the monthly production of these fighters reached an astonishing 881 aircraft at the height of the ramp-up. This production volume was more than twice the total output of all German single-engine fighters combined. Aircraft such as the Messerschmitt Bf 109s, Focke-Wulf FW-190s, and various newer models. The scale of manufacturing underscored the industrial disparity and the logistical superiority of the Allied war effort. Beyond sheer numbers, the quality and reliability of American aircraft significantly outstripped that of their German counterparts. The Mustangs came equipped with dependable engines constructed to high engineering standards, minimizing mechanical failures during critical missions. The aircraft also carried advanced and precise instrumentation, along with radio equipment that functioned reliably under combat conditions, an essential advantage that German fighters lacked due to their often inferior manufacturing quality and the deterioration of late-war German industrial capability. German fighters frequently suffered from mechanical failures, poor maintenance, and substandard parts, a direct result of the widespread shortages of materials, the use of makeshift substitutes, and the disorganization of their maintenance infrastructure. American pilots benefited from a robust maintenance system operated by highly trained ground crews who had access to genuine spare parts, proper tools and comprehensive technical manuals. Their aircraft were regularly serviced and checked, ensuring optimal performance during combat. By contrast, German ground crews faced mounting difficulties. Supply shortages meant they often had to rely on substitute materials, and the maintenance facilities were increasingly dispersed and understaffed. This logistical chaos compromised the operational readiness of German fighters and contributed to their declining combat effectiveness. The disparity extended into pilot training, which became a critical factor in the outcome of aerial engagements. American pilots generally entered combat units with substantial flight hours, typically between 200 and 400 hours, covering everything from basic flying skills to advanced combat tactics. Their training emphasized formation flying, instrument navigation, and combat maneuvers under a variety of weather conditions, preparing them thoroughly for what they would face in combat. Such comprehensive preparation was reflected in their performance, as they could execute complex tactics with confidence and adapt swiftly to dynamic situations. In stark contrast, the German pilot training program had deteriorated severely by late 1944. Persistent fuel shortages, the loss of training facilities, and the scarcity of experienced instructors led to the drastic shortening of training periods. New pilots often arrived at frontline units with barely 100 hours of flight experience, minimal or non-existent training in combat tactics or instrument flying, and little preparation for the realities of dogfighting and large-scale air operations. Many of these inexperienced pilots found themselves ill-equipped to face the seasoned American flyers, flying aircraft that, while still formidable, were often superior in reliability and performance. This mismatch in pilot experience and aircraft quality had devastating consequences for German air defenses. The losses among German fighter pilots increased sharply and became increasingly unsustainable as the war progressed into 1944 and early 1945. Veteran pilots, who had spent years honing their skills and understanding how to maximize the remaining strengths of their aircraft, were progressively replaced by a wave of less experienced, often poorly trained newcomers. The attrition rate among German pilots soared, leading to a decline in unit effectiveness and morale, further compounding the Luftwaffe's difficulties. In summary, the combination of technological advances, superior industrial production, reliable aircraft and equipment, thorough pilot preparation, and effective logistics enabled the Allies to establish air supremacy over Germany. This dominance not only during the intense and relentless aerial battles of late World War II, the German Luftwaffe found itself increasingly crippled not solely by the resilience of its adversaries but by its own dwindling capacity to train and replace its pilots effectively. The brutal reality was that, under the pressures of continuous combat, pilots who had only received minimal, and often hastily arranged, training were succumbing or being wounded at a rate far faster than any replacement pilots could be prepared. Even when new recruits did undergo the abbreviated training programs, the stark truth remained. These inexperienced pilots managed to survive only a handful of missions on average before they were either shot down or forced to bail out. Those fortunate enough to escape the crash had little choice but to abandon their aircraft, while the less fortunate faced death. Such losses represented a catastrophic hemorrhaging of the Luftwaffe's most vital and irreplaceable resource: skilled, seasoned pilots who possessed the critical knowledge, instinct, and judgment necessary for survival and tactical success. The tempo of destruction and attrition was so rapid that the entire enterprise was unsustainable in the long run, leaving the Luftwaffe increasingly outmatched and underprepared. In the midst of this dire situation, the German military utilized the Wonder Zirkus Rosarius demonstrations, exhibitions designed to showcase the capabilities of captured enemy aircraft, to reveal the stark realities of modern aerial warfare to their own pilots before they faced similar threats for real in combat. These demonstrations provided a stark, tangible understanding of what pilots might encounter, offering them a chance to witness firsthand the superior performance of Allied aircraft. While this advanced awareness theoretically enhanced their chances of survival by giving pilots a realistic preview of the enemy's strengths and tactics, it also delivered a brutal and unambiguous message. The overall strategic situation for Germany was deteriorating quickly across all facets of the air war. An understanding of the opponent's technological and operational advantages made it painfully clear that the German forces were falling behind in the technological arms race. Pilots who had the opportunity to fly or observe demonstrations of the captured P-51 Mustang, the renowned American fighter aircraft, gained an uncomfortable but invaluable clarity about the enemy's technological edge. These experiences underscored the fact that Allied fighters, particularly the Mustang, boasted significant and fundamental performance advantages in crucial aspects: speed, operational range, high-altitude endurance, and sheer numbers. Such knowledge was not merely tactical trivia. It was a sobering reality check that underscored the formidable challenge German pilots faced. As early as late 1944 and continuing into early 1945, this awareness inflicted severe psychological strain, as the strategic disparity became impossible to ignore, eroding morale and confidence among German aviators. Despite the daunting circumstances, a small group of German test pilots who had the chance to fly the captured P-51s extensively, through numerous test flights and mock combat exercises, began to develop a grudging but genuine respect for American engineering and design philosophy. This respect was rooted in their direct experience of the aircraft's coherent engineering approach, which thoughtfully prioritized characteristics most vital for the strategic missions at hand. These pilots recognized that the Mustang's design was not merely a product of technological happenstance but the result of deliberate, intelligent compromises. The aircraft sacrificed some features, such as exceptional turn performance optimized for dogfighting, to instead emphasize speed, extraordinary range, and high-altitude operational capabilities. These characteristics allowed it to escort long-range bombers deep into hostile territory and remain effective throughout the mission duration. This approach reflected a sound and pragmatic engineering judgment, prioritizing mission-specific qualities over maximizing pure combat agility. The design choices exemplified a clear focus on operational objectives, deliberately balancing the aircraft's capabilities to best serve its strategic role rather than pursue theoretical performance maxima that might have been less useful in actual combat scenarios. Furthermore, the aircraft's relative ease of mass production impressed German engineers, who understood firsthand the challenges of manufacturing advanced military hardware. The Mustang's design facilitated true mass production through modular construction techniques that enabled parallel manufacturing processes, standardized components that reduced complexity, and features deliberately simplified to streamline assembly operations. These design choices enabled rapid and large-scale production, ensuring the aircraft could be produced efficiently and in sufficient numbers to meet operational demands. In essence, the American approach to aircraft manufacturing reflected a sophisticated understanding of both engineering principles and industrial logistics. The Mustang epitomized this philosophy, integrating advanced aeronautical features with manufacturing techniques that allowed for swift and cost-effective production, a combination that made it a formidable ally in the Allied arsenal. The result was a fighter aircraft that not only outperformed its German counterparts in key performance metrics but also embodied a strategic and industrial philosophy of efficiency and innovation, traits that proved decisive in shaping the outcome of the air war in Europe. In the realm of aircraft manufacturing, certain factories possessed the capacity to produce the legendary Mustang in large volumes, thanks to their foundational design principles, which inherently accounted for efficient and consistent production processes right from the initial concept. These facilities could churn out numerous aircraft while maintaining an exemplary standard of quality, precisely because the aircraft's core design was crafted with manufacturability in mind, ensuring smooth production lines and reducing the likelihood of defects or delays. Contrasting this, German aircraft development often took a different approach. Rather than focusing on making the manufacturing process straightforward and efficient, their designs frequently prioritized peak performance, pushing the limits of aeronautical engineering. This mindset resulted in aircraft that, while remarkably capable in their operational roles, were often complex to build. The intricate details and demanding construction techniques meant that even under the best possible circumstances, such as peacetime production, these planes were labor-intensive and time-consuming to assemble. When the tides of war turned against Germany, and resources grew scarce, these manufacturing challenges became even more pronounced. The deteriorating conditions, such as shortages of essential materials and the dispersal of production facilities to avoid Allied bombing raids, further hampered quality control, making it increasingly difficult for German engineers and workers to maintain the high standards needed for reliable aircraft production. One notable example illustrating the disparity in manufacturing capabilities was the American production of the Packard V1650-3 Merlin engine, which powered not only the early models of the P-51 Mustang flown by pilots like Fraser but also a significant portion of the initial production aircraft. The Packard Company succeeded in licensing and manufacturing the complex Rolls-Royce Merlin engine stateside, producing many thousands of these power plants with astonishing consistency and high quality. This achievement was critical because the Merlin's intricate design, featuring a sophisticated two-stage supercharger coupled with an intercooler, delivered outstanding high-altitude performance, a key advantage in aerial combat. American engineers and manufacturers managed to produce engines that were not only powerful but also reliable and easier to maintain in the field, despite the engine's inherent complexity. In stark contrast, German inline engines such as the Daimler-Benz DB605 faced mounting difficulties in maintaining quality as the war progressed. By the year of 1944, factory conditions and material shortages had led to a decline in production standards. Severe shortages of high-quality materials compelled the use of substitutes, which compromised engine integrity. Additionally, the dispersal of production across various locations, an effort to avoid destruction from Allied bombings, further disrupted quality control processes. The result was an increase in manufacturing defects and decreased reliability of German power plants, which affected aircraft performance and operational readiness. The psychological toll on German pilots who flew these increasingly unreliable aircraft should not be underestimated. These men entered the conflict with a firm belief in their training, their aircraft's capabilities, and their tactical doctrines. Confidence built on the assumption that they faced opponents with inferior technology and skills. However, by late 1944, after years of intense combat and the exposure to captured Allied aircraft, especially through programs such as the Wonder Zirkus Rosarius, this confidence began to erode. German pilots gradually recognized, often painfully, that they were up against adversaries who held decisive advantages. The Allies' aircraft, particularly the Mustangs and other fighters, outperformed German planes in virtually every significant category: altitude endurance, speed, maneuverability, and armament. Moreover, the Allies enjoyed overwhelming numerical superiority, better logistical support, more comprehensive training regimes, and superior intelligence gathering. This combination meant that engaging in aerial combat against these opponents often felt like a hopeless endeavor, bordering on a form of fatalism where pilots resigned themselves to probable death or severe injury with each sortie. The accounts of former Luftwaffe pilots and post-war interviews from this difficult period vividly describe the sense of despair as Allied fighter formations appeared on the horizon. Many pilots reported the realization that no tactical maneuver could successfully evade or outrun the American fighters escorting their bombers. Attempting to engage Mustangs at high altitude, where German aircraft were at a severe disadvantage in terms of speed, climb rate, and overall performance, often resulted in a lopsided and hopeless fight. Conversely, avoiding combat meant permitting massive bombers to strike their targets unopposed, which contributed directly to the collapse of Germany's military capabilities and industrial infrastructure. Faced with these dire choices, neither option, the futile fight nor the capitulation, offered any satisfactory resolution, and the dilemma underscored the tragic decline of German aerial power in the final years of the war. From a military perspective rooted in professionalism and strategic analysis, the harsh reality faced by German fighter pilots during the final year of World War II was one of increasingly stark and unambiguous choices. As their overall strategic position worsened beyond any hope of reversal, these pilots and their units found themselves caught in a relentless struggle for survival amid dwindling resources and encroaching Allied dominance. Despite this dire situation, the German unit known as Wonder Zirkus Rosarius continued its operations into the early months of 1945, performing demonstrations using various captured American aircraft, primarily the formidable P-51 Mustang, for as long as aviation fuel supplies permitted and as long as it remained feasible to maintain operational airfields. These activities persisted as long as the ground situation allowed, meaning as long as the Allies' advancing armies from both the eastern and western fronts did not render safe transportation and operational readiness impossible. As the Allied push into German territory intensified, with forces advancing from multiple directions, moving relentlessly deeper into the heart of Germany, the logistical and safety constraints surrounding these demonstration missions grew more severe with each passing week. The ability of the German units to reach their training or testing sites was gradually compromised, with the logistical burden increasing due to the hostilities and destruction inflicted by the Allies. In the end, the entire program was forced to cease as the collapse of German military organization reached a point where even specialized units, such as test and evaluation groups that had once been prioritized for scarce resources, could no longer sustain their activities. The systemic disintegration of the Wehrmacht and Luftwaffe rendered such efforts moot. The final fate of the captured P-51 Mustangs operated by German forces remains shrouded in uncertainty, largely due to incomplete archival records and the chaos that accompanied Germany's final downfall. Many of these aircraft were undoubtedly destroyed on the ground during the intense Allied air assaults on German airfields, which intensified dramatically throughout 1945. Some aircraft may have been deliberately destroyed by retreating German units, aimed at preventing their capture by the advancing Allied forces. Others perhaps managed to survive the chaos and were later recovered by the Allies as they pushed into Germany's heartland. However, detailed documentation concerning the specific recovery or destruction of individual aircraft is scarce or lost in the tumult of those final days. Despite these uncertainties, the systematic testing of captured Mustangs provided German pilots with an invaluable repository of tactical intelligence. They gleaned insights into American aircraft capabilities, understanding optimum engagement parameters, uncovering exploitable weaknesses, and assessing performance characteristics. This knowledge, while crucial, ultimately proved insufficient to level the playing field against the overwhelming technological and numerical superiority of Allied forces by 1944. The Germans knew theoretically that the Mustang could outclimb, outpace, and outrange their fighters, knowledge that offered some strategic comfort, yet practical benefits remained limited when German pilots were still ordered to engage these aircraft in defensive roles over German territory, often under direct command with little room for tactical innovation. The German testing and demonstration program was, in essence, a highly sophisticated effort to counter the Allied advantages through tactical experimentation, strategic adaptation, and enhanced pilot education. However, such measures could not compensate for the fundamental disadvantages faced by the Luftwaffe. These included inferior aircraft performance, severe numerical shortages, dwindling fuel supplies, and a chronic lack of spare parts and experienced maintenance personnel. All these issues compounded to make effective operational use increasingly impossible. An extraordinary story from this period involves Lieutenant Thomas Fraser, who piloted a P-51 Mustang, bearing serial number 4,324,825, whose legacy extended well beyond his initial combat role. Following a forced landing on D-Day in France, Fraser's aircraft, initially a casualty of combat, took on a new significance. It became a potent symbol of American engineering prowess and technological superiority, turning into an unintended but powerful lesson for German pilots. The wreckage of Fraser's Mustang laying in a French field served as a tangible demonstration of the capabilities of American aircraft, something that no amount of German propaganda could effectively counter. It epitomized the reality of Allied dominance in air power, a truth that was increasingly impossible for the Germans to deny as the war drew to its bitter conclusion. The aircraft played a crucial role in educational and training efforts until its tragic loss in December of 1944. Over the course of its operational life, it traveled extensively across German-held territories, providing invaluable hands-on experience and offering a stark, realistic assessment of enemy capabilities to hundreds of Luftwaffe personnel. These missions and evaluations significantly contributed to the German understanding of Allied air power, even in the face of a deteriorating strategic situation. The story of the captured Mustangs in German service vividly illustrates the meticulous and professional approach adopted by the Luftwaffe when it came to understanding and assessing the strengths of enemy aircraft. Despite Germany's declining strategic position and limited resources, their forces prioritized a systematic effort to recover, repair, and operate these captured aircraft under controlled conditions. Rather than relying solely on fragmented combat reports or uncertain intelligence assessments, they invested considerable effort and scarce resources into pilot training, aircraft maintenance, and flight testing. This comprehensive approach aimed to gain accurate, detailed insights into the aircraft's performance, capabilities, and weaknesses. This disciplined and methodical practice of tactical intelligence collection reflected the best standards for military organizations seeking to correctly evaluate an adversary's true strength. It was a clear demonstration of the German military's commitment to scientific precision even during the waning years of the war. The Wonder Zirkus Rosarius program, which was dedicated to examining and testing captured Allied aircraft, proved that even the most advanced intelligence gathering, professional expertise, and systematic analysis could not compensate for the fundamental material and strategic disadvantages faced by Germany. No amount of technological insight or operational knowledge could bridge the gap created by a lack of resources, industrial capacity, and strategic depth. German test pilots who flew the captured Mustangs amassed crucial information about the aircraft's handling characteristics, performance metrics, and potential tactical uses. However, This hard-earned knowledge confirmed what many Germans had already suspected or understood. Allied aircraft, particularly the Mustang, had significant and decisive performance advantages that German engineering and industry, constrained by wartime resource shortages, simply could not emulate in the final years of conflict. These advantages in speed, range, and agility underscored the limitations of German technological progress under increasing strain. This confrontation with the Mustang's capabilities was a reflection of the broader German military experience during the last phases of World War II. Across all theaters and branches of service, initial confidence in German technological superiority and tactical innovation gradually eroded in the face of mounting evidence. Allied forces, backed by vast industrial capacity, access to critical strategic resources, and enormous manpower reserves, had developed technological and logistical capabilities that often outpaced German achievements. The Mustang, as a prime example, embodied these broader advantages, showcasing the results of American engineering ingenuity and industrial might. American aircraft designers engineered the P-51 Mustang to excel precisely at its core mission, providing long-range escort for strategic bomber missions deep into enemy territory. This aircraft was produced in immense quantities, maintaining consistent quality despite its complex design, a testament to the efficiency and scale of American manufacturing. American pilot training programs prepared airmen to extract maximum performance from the Mustang in combat, teaching tactics that leveraged its speed, range, and agility. Meanwhile, the German forces studied and analyzed these advantages meticulously through programs like the Wonder Zirkus Rosarius, which provided valuable insights without the capacity to effectively replicate or counteract them due to strategic and material limitations. The technical sophistication of the P-51 Mustang challenged German industry and pilots alike, exposing the stark performance gap that could not be bridged in the final years of the war. Despite their efforts in capturing and analyzing these aircraft, German engineers and pilots faced insurmountable obstacles rooted in resource scarcity and strategic disadvantages. In the end, the encounter with the Mustang's capabilities underscored the fundamental material and technological disparities that defined the closing chapters of the conflict for Germany. This aircraft not only symbolized American industrial and technological triumph but also served as a stark reminder of the shifting balance of power during the late stages of the war. The sophisticated engineering, mass production, and comprehensive training that characterized the P-51 Mustang represented a broader wave of Allied superiority, one that Germany's strained war effort could not match or overcome. The advent of the P-51 Mustang fundamentally challenged and ultimately dismantled long-held assumptions held by German military strategists about American engineering prowess, assumptions that had been meticulously reinforced through wartime propaganda. For years, official narratives had depicted American industry as capable only of producing simple, rugged, and mass-produced equipment, while portraying American engineers as lacking the sophistication and finesse necessary for intricate, high-performance designs. These portrayals suggested that the United States could deliver large quantities of durable but unsophisticated hardware, whereas the Germans believed that true engineering excellence was a domain reserved for their own more advanced and refined technological developments. However, the arrival and deployment of the Mustang decisively demonstrated that such beliefs were fundamentally flawed. The aircraft's design provided irrefutable evidence that American engineers possessed the skill and ingenuity to develop highly refined, aerodynamically advanced aircraft capable of matching, and in many cases surpassing, German technological standards in critical strategic aspects. The Mustang's wing design, for example, was the product of cutting-edge aerodynamic research, skillfully applied in a high-volume production context, illustrating an impressive integration of scientific innovation and manufacturing efficiency. Its fuselage and wing structures reflected meticulous engineering aimed at optimizing performance, range, and durability. Complementing this, the Packard-built Merlin engine, the model FE 16530, was a testament to American manufacturing capabilities in producing complex, high-performance power plants at scale. The engine's consistent quality, reliability, and power output showcased that the United States had developed the capacity to mass-produce sophisticated mechanical systems without sacrificing precision or performance. The aircraft's overall systems integration further proved that American engineers could effectively harmonize multiple technological components, propulsion, aerodynamics, armament, and avionics, into a single, coherent, combat-ready weapon system. This careful balancing of various competing demands resulted in an aircraft that was not only capable of fulfilling its intended strategic roles but did so with remarkable efficiency and reliability. For the German pilots who had the opportunity to fly the Mustang extensively, the aircraft's superiority could not be dismissed as crude or unsophisticated, as propaganda had suggested. These seasoned pilots experienced firsthand the aircraft's exceptional handling qualities, which remained consistent across its entire flight envelope. They observed that the Mustang performed outstandingly in the mission profiles that mattered most strategically, whether that was high-altitude interception or long-range escort. More importantly, they recognized the thoughtful and meticulous design that underpinned every system of the aircraft, each element reflecting refined engineering and a clear understanding of operational demands. This direct, unfiltered contact with the Mustang compelled even the most skeptical German pilots and commanders to acknowledge a significant gap between their preconceptions and reality. They had to admit that American technical and engineering capabilities far exceeded their earlier assumptions, with implications that extended far beyond aircraft design. It prompted a broader reconsideration of American industrial strength, technical education, and overall proficiency in engineering, areas previously underestimated or dismissed. The strategic significance of the Mustang's capabilities became particularly apparent in the context of the Allied aerial campaign targeting Germany. The aircraft's unique combination of long-range endurance, high-speed performance, and exceptional handling made it indispensable for providing effective bomber escort deep into enemy territory, an operational milestone that no other Allied fighter could achieve before its widespread deployment in early 1944. Prior to the Mustang's entry into service in large numbers, Allied heavy bombers lacked reliable, long-range escort fighters capable of accompanying them throughout the entire mission profile from England to targets inside Germany and back. Earlier escort fighters, such as the Republic P-47 Thunderbolt and the Lockheed P-38 Lightning, despite their impressive capabilities in other respects, were hamstrung by insufficient fuel endurance. Their limited range meant they could only stay with the bombers until reaching a certain point, after which they had to turn back to base, leaving the bombers vulnerable during the most perilous segments of their missions. German fighters quickly learned to capitalize on this weakness, waiting for escorts to run low on fuel before launching attacks during critical moments when the bombers were most exposed. This persistent vulnerability resulted in unsustainable levels of bomber losses, which ultimately forced a halt to the most dangerous deep penetration raids into Germany. The arrival of the Mustang, however, revolutionized these operations by bridging this critical gap. Its long-range capability enabled it to accompany bombers throughout every phase of their missions, effectively providing continuous, reliable escort coverage regardless of how far the aircraft had to fly or how long the mission extended. German fighters no longer enjoyed periods of uninterrupted opportunity to attack unprotected bombers, as the Mustang's endurance and performance kept the bomber formations under sustained protective cover. This operational transformation had far-reaching consequences for the Allied strategic bombing campaign. It not only increased the survivability of the bombers and enhanced the overall effectiveness of the raids but also altered the very nature of aerial combat over Europe. The Mustang's presence meant that German fighters could no longer decisively exploit the long-range escort gap, forcing them to reconsider their tactics and reducing their ability to inflict crippling losses on Allied air forces. During the final years of the conflict, German pilots were instructed to engage Allied fighters directly, rather than solely attempting to attack the bomber formations they escorted. This shift in tactical doctrine substantially heightened the dangers faced by German pilots during every interception mission, as engaging enemy fighters in combat was inherently riskier than attacking vulnerable bombers. These increased risks were compounded by the growing numerical superiority of Allied aircraft and a decline in the overall quality of German pilots, which resulted from shortened training periods and a rapid turnover of experienced personnel. Consequently, the introduction of the P-51 Mustang as an escort fighter transformed the operational landscape for Allied bomber raids over Germany. The Mustang's formidable capabilities allowed the Allies to sustain strategic bombing campaigns with greater effectiveness, whereas German efforts to intercept and combat these precision attacks became progressively more costly, less effective, and ultimately futile. In the midst of these developments, the German Luftwaffe undertook an extensive and meticulous technical evaluation of captured P-51 Mustangs across multiple testing facilities. These evaluations were particularly thorough at Göttingen, where German engineers conducted detailed, systematic performance assessments. The resulting technical reports documented the Mustang's capabilities in a comprehensive manner, providing a wealth of data on various performance parameters. These assessments measured the aircraft's speed at different altitudes, analyzed climb rates across the entire altitude spectrum, determined the absolute ceiling and operational range under various configurations, and examined handling characteristics throughout the aircraft's performance envelope, all under controlled testing conditions designed to ensure accuracy and consistency. German engineers meticulously compiled these findings into detailed technical reports, which not only compared the P-51's performance directly with contemporary German fighter aircraft under similar testing circumstances but also analyzed the specific design features responsible for its superior performance. The circulation of these reports within German aviation circles facilitated the transfer of crucial technical knowledge. They informed aircraft designers about the innovative approaches employed by the Allies, provided tactical planners with precise performance data vital for operational planning, and offered commanders realistic assessments of Allied capabilities. This intelligence proved invaluable in shaping Germany's strategic response and modernization efforts. The technical reports corroborated the observations made by combat pilots engaged in actual aerial encounters. The Mustang demonstrated significant and decisive advantages in key performance areas critical to its primary role of bomber escort. Systematic analysis of the aircraft's capabilities highlighted its exceptional range, which was essential for conducting long-range escort missions deep into enemy territory. Its superior high-altitude performance, enabled by an advanced two-stage supercharged engine, allowed it to operate effectively in the high-altitude environments where many aerial battles took place. Furthermore, the Mustangs achieved high maximum speeds, providing tactical flexibility in combat scenarios. In addition to raw speed, the aircraft's handling characteristics stood out as particularly harmonious, reducing pilot workload and enabling effective maneuvering during combat. The detailed technical evaluations identified several design features that contributed to these advantages, including the aerodynamically efficient wing design that minimized drag, the powerful and sophisticated supercharged engine installation offering reliable high-altitude performance, and the large internal fuel capacity complemented by external tanks that ensured extended operational ranges. The integration and systems architecture within the Mustang reflected careful engineering, allowing the aircraft to perform reliably and efficiently across various combat conditions. This collection of technical intelligence led to the clear conclusion that existing German fighter designs required significant enhancements if they were to stay competitive with the latest Allied aircraft. The reports emphasized that current German fighters, while formidable, needed major improvements to match the Mustang's combination of range, speed, altitude performance, and handling. Recognizing this urgency, Germany launched several ambitious fighter development programs during the year 1944, aiming to incorporate advanced technologies capable of countering Allied air superiority. Among these efforts were initiatives to develop new aircraft equipped with more powerful engines, improved aerodynamics, and innovative systems designed to close the performance gap that the Mustang and other Allied aircraft had highlighted during recent operational encounters. The Fowler-Wolf FW190D, equipped with an inline engine designed to enhance high-altitude performance, represented an important step forward in German aircraft development. This model was part of a broader effort to improve the capabilities of existing fighters, aiming to address specific operational challenges faced at higher altitudes. Parallel to this, the Fowler TAR-152 was developed as a specialized high-altitude fighter, optimized to operate effectively where the traditional Luftwaffe fighters struggled. Alongside these developments, numerous revolutionary designs emerged, jet-powered and rocket-assisted aircraft, that aimed to fundamentally transform aerial combat by surpassing the limitations of piston engines. These ambitious projects clearly showcased the recognition among German aeronautical engineers and military strategists that the prevailing fighters, such as the Messerschmitt Bf-109G and the Focke-Wulf FW-190A, could no longer keep pace with the increasingly advanced Allied aircraft, notably the P-51 Mustang. The Mustang's superior performance in critical areas, speed, altitude, range, and maneuverability, meant that the Germans needed to develop new, more capable aircraft if they hoped to counteract the Allied air superiority effectively. Despite this understanding and the considerable technological effort invested, Germany's capacity to realize these advanced aircraft was severely hampered. Material shortages, exacerbated by relentless Allied bombing campaigns that targeted production facilities, combined with logistical delays and resource constraints, prevented many of these promising designs from reaching operational status in sufficient numbers. As the war progressed and the overall strategic situation worsened, these limitations meant that even the most innovative aircraft remained largely on paper or in prototype stages, unable to influence the course of the conflict or reverse the growing dominance of Allied air power. Germany's most audacious attempt to leapfrog the performance of piston engine fighters was embodied in the jet-powered Messerschmitt M262, often regarded as the most successful example of revolutionary turbojet technology developed by the Germans. The M262 boasted significant advantages in both speed and firepower, making it a formidable adversary against Allied bombers when flown skillfully by experienced pilots who knew how to maximize its capabilities. Yet, this aircraft also faced critical technical and logistical challenges. Chronic engine reliability issues limited the aircraft's operational availability, reducing the number of planes that could be deployed effectively. Furthermore, The M262 required extensive concrete runways for takeoff and landing, features that were increasingly vulnerable to Allied attacks and difficult to maintain under ongoing bombing campaigns. The aircraft's impressive technological advantages, while notable, were ultimately insufficient to overcome the broader strategic disadvantages faced by Germany. The rapidly shrinking industrial base, dwindling fuel supplies, and deteriorating pilot training programs all contributed to the decline of the Luftwaffe's fighting effectiveness. By the final year of World War II in Europe, the German Air Force was undergoing a systematic disintegration as an organized and effective fighting force capable of conducting sustained operations. The combination of catastrophic pilot losses, severe and worsening fuel shortages, and relentless Allied numerical superiority rendered German air defenses increasingly ineffective, regardless of individual pilots' skill, courage, or ingenuity. In a last-ditch effort to gather tactical intelligence and maintain some degree of operational effectiveness, the Germans continued to operate and test captured Allied aircraft. This program aimed to understand better the capabilities of enemy planes like the P-51 Mustang, which had proven to be a formidable opponent. These efforts, though ultimately constrained by the overwhelming material and strategic disadvantages, provided valuable insights for as long as they could be sustained. Toward the war's end, the German pilots who had flown captured Mustangs, aircraft that epitomized Allied technological and tactical advancements, faced a mixture of complex emotions. While many pilots recognized and appreciated the engineering marvels embodied by aircraft like the P-51, they also faced the harsh reality of Germany's imminent defeat. Despite their skills, dedication, and the bravery inherent in their service, it was clear that victory was no longer attainable. They understood that the total and unconditional capitulation was inevitable, marking the end of Germany's hopes of turning the tide of the war through any remaining technological or tactical advantage. Having witnessed firsthand the overwhelming material superiority of Allied forces in virtually every aspect of military power, ranging from superior aircraft and weaponry to greater production capacity, the captured aircraft testing programs served as a stark reminder of the technological gulf that had developed. It underscored how, despite individual acts of heroism and engineering ingenuity, the Germans found themselves increasingly unable to stem the tide of Allied dominance, a reality that ultimately sealed the fate of the Luftwaffe and the wider German war effort. The testing program involving the formidable P-51 Mustang stands out as a compelling and instructive chapter in the history of aviation during the Second World War. It exemplifies how dedicated military organizations, even when faced with desperate and challenging circumstances, relentlessly pursue a deeper understanding of their adversaries' strengths and weaknesses through systematic collection and analysis of intelligence. This program was not merely a matter of curiosity. It served a strategic purpose by providing German pilots with first-hand experience and critical insights gleaned from captured aircraft, which held significant tactical value. Through these direct encounters with the Mustang, German pilots could learn much about its handling, performance, and technological features, knowledge that could potentially influence their combat tactics. However, despite this valuable intelligence, it ultimately proved insufficient to rectify the underlying disadvantages that the Germans faced throughout the latter years of the war. The fundamental imbalances in industrial capacity, resource availability, advanced technological development, and the level of training among personnel created barriers that even detailed technical understanding could not overcome. These disparities defined the broader context of the air war during the years of 1944 and 1945, shaping its course and outcome. German military forces displayed extraordinary resilience during this period, fighting with notable bravery, tactical ingenuity, and a high degree of professionalism. Yet, they encountered opponents equipped with far more abundant resources, superior machinery, extensive training programs, and a strategic positioning that favored their operational capabilities. These advantages ultimately proved decisive in the conflict, overshadowing the tactical and technical gains that the Germans could achieve through their efforts. The candid admission by German test pilots that they had never encountered handling qualities comparable to those displayed by the Mustang represented a significant professional acknowledgement. Such a statement was not merely an expression of admiration but a clear recognition of American engineering ingenuity and a realistic appraisal of the performance gaps faced by German pilots during combat. It signified a moment where direct personal experience challenged and refined existing perceptions, marking a departure from reliance on propaganda or second-hand reports. This honest acknowledgement, derived from tangible experience rather than ideological bias or superficial intelligence reports, underscored a vital truth. Confronting uncomfortable realities often necessitates engaging directly with the subject, accepting facts that may be difficult to reconcile with preconceived notions. The lessons learned from the Wonder Zirkus Rosarius and similar programs extended beyond immediate tactical insights. They served as enduring examples of the importance of meticulous intelligence gathering, the value of technical competence in evaluating enemy capabilities, and the courage to face and acknowledge inconvenient truths, even amid the most demanding strategic conditions. Overall, these efforts in systematic evaluation and honest appraisal demonstrated that military success depends not only on technological superiority but also on the willingness to pursue knowledge rigorously, confront realities head-on, and adapt strategies accordingly. The legacy of such initiatives remains a testament to the indispensable role of professionalism, integrity, and relentless inquiry in achieving military effectiveness amidst the complexities of modern warfare.